Hello everyone, in this video we are going to learn loading analysis and their results. Okay, in my previous videos you can see how to assign loads and how to draw model. Okay, after all these parts the next step is the loading and analysis and the final is results. Okay, in this video I'm going to tell you how to give the loads, how to make analysis, and the important is how to check the results of your building. Okay, for this thing you have some prerequisites. For example, is 456, is 875, part 1, part 2, part 3. Okay, till wind load, or for seismic it is 1893 2000 and 13920 for ductile detailing. But in this video I'm going to tell you dead load, live load and wind loads, okay, for a particular building. This is the defined load patterns. Okay, that is I have already mentioned my previous video. Okay, I will tell you how to give all these loads. Okay, here you can see the commands and the name of input forms. Okay, the shell loads are uniform, some is non-uniform, temperature, wind loads. Okay, these define load combinations. The load combinations are automatic or manual also. For example, you can give concrete or steel is differently for a building, that is load combination. Okay, I will tell you in software directly. Like this you can just add a default design combination, it will give you default combination, otherwise you can add a new. Okay, the first thing is you have to know the manual calculations for a bay dead load and wind load. Okay, but for a building is 875, for a residential building particularly is 875 define 2 to 3 kilonewton is live load. Okay, and the next last step is just check model, set load cases to run, and the run analysis. Okay, the run analysis will show you and it will give you bending moments, shear force diagram and all the things. Okay, shell stresses, different types of bending, deflections, all it will give you at display options. Okay, I will show you in software directly. Okay, till here you know how to make the grids and all the things. Okay, firstly I am going to defining materials. Defining the section, column, next is beam, defining shell, defining a diaphragm. For a wind load, it is important. You can add a diaphragm. Okay, you can check in IS 1893. Okay, the definition of diaphragm is mentioned. Okay, if you want to add new, it's rigid, semi-rigid, whatever. Want to modify this, it's rigid. Okay, defining the load, it's dead load, live load is by default, and wind load is I'm going to give in x direction. Wind type is wind, and IS 875 2050. Simply click add, and y direction, click add. Okay, just modify it, lateral load. Okay, exposure and pressure coefficient at the diaphragm. Okay, now I'm going to give extend to diaphragm. You can give the shell object, it is depend on your building and analysis type. Now I'm going to give extent of diaphragm. Okay, then next is window exposure parameters. Okay, this is also available in table number 5 IS 875 2015 part 3. Okay, you can go and check there how to define. The first thing is wind exposure width data, it is also available. Okay, as per my building I'm going to 0. Okay, and windward coefficient is building, it is depend on your building height ratio. So it is 0.7. Okay, it is 0.5, and the wind coefficient also available in IS 875 annex first. There you can find wind speed. It is depend on your city, but now I'm going to give it is maximum, that is 50. Terrain category, there are 4 types of category. Terrain categories are available depend upon your building location. Okay, the building are between two high rise building. Next is if your building is located at a highly wind speed area, for example in Himalayan region, or wind pressure is maximum. Okay, it is depend. And other thing is locality of your building, it's depend on your category. This terrain category I'm going to give it is 2. Okay, importance factor. Okay, the importance factor is mentioned in IS 875. Okay, there you can check as per your building. For example, the first is 1.1 1.13, sorry, 1.30 is for school building, communication or communal building. Okay, different types of commercial buildings, it is 1.30. Then importance factor is 1.15 is for industrial, and 1 is for residential. So my building is residential, that's why I have put it 1. Risk coefficient also I have calculated from IS 875. Okay, you can check there, it is 1. And topography also is my for terrain 2, it's I'm going to give is 1. Okay, then exposure height. Okay, my top story is story 4, that's why I have put it 4. Then bottom story is base, that's why I have put it base. If you have parapet, then you can put a parapet. Now I'm going to give parapet is 1 meter. Otherwise, if you don't want, you can deselect it. Okay, simply click OK. Similarly for y direction, modify lateral load, same for diaphragm extent. Now here some changes are there. Okay, now it is not at 0, it is at 90. Okay, click OK. Here exposure at windward coefficient is uh, for my building is calculated from same as table number 5, as 875 table number 5. Okay, part 3 you can check there and calculate as per your building. It is 0.5 and it is minus 0. 0.2, 2.7, array 0.7. Okay, this is for y direction. Simply click OK. Then the next is shell uniform load set. Okay, you can add a new load set. Just going to add all the loads. Okay, add sly load, wind load, and wind y. Loads are in gravity direction. Okay, this is the note. So I have added wind load and y load. This for showing how to add and delete. That's why I have shown this note and all these two things. Okay, you can delete from here. Okay, simply click OK. Okay, here you can modify copy load set. You can copy it, delete. Okay, I'm going to click OK. Then defining load combinations. Okay, now I'm going to add by default design combinations. Simply click add. For concrete frame, convert to user combination and OK. Okay, all these combination I have got. Click OK. Here you can see in load cases, the load case types for dead load, live load, all are in linear static. Okay, then all things have done. Okay, I am going to draw first. This is slab 2. I have named it. Come to the base, make it story 1, select, delete. Okay, then select the joint. Then after selection, click on assign joint. Okay, see here assign joint and distance. I'm going to make it fast distance, apply and okay. Okay, the next step is defining the loads and assigning the loads on your building. Okay, then make it all story. Okay, it is all story 1. Click on select object type. Okay, make this. Okay, then click on column, select all the column, assign frame load distributed. Okay, that is dead load add to existing, it's gravity. Now I'm going to calculate the dead load for 0.45 into 0.4 into 25 is 4.5. Okay, for a dead load, apply. Okay, here you can see. Okay, the next is select live load, H2 as per IS 875, apply, then okay, then the beam. Now I am going to add directly wall cladding, auto cladding. So here only calculating the beam load. Beam is 0.35 into 0.3 25, 2.625. Okay, frame load distributed 2.625 at existing beam, apply. Okay, and it is depend on your distance, whatever distance you have given, the distance 1 2 3 4 4 sections it will apply. Okay. Then next is live load, select, it is 2 and apply, and okay. Okay, then next is floors, select, assign, shell load, uniform load. Okay, that is dead load. Okay, it is also we have to calculate for 150 thickness, unit load 0.150 into 25, 3.75, 3.75 kilonewton meter square. Okay, apply for a shell. And the next one is live load, select, apply, pause. Shit. Just a second. Okay, live load, first click, live load is 2 and apply. Okay, now correct. Okay, then I'm going to just give wall cladding. Okay, auto wall cladding, you can draw auto wall cladding for floors. Okay, here you can see auto wall cladding I have given, and now I'm going to give in this direction is wind load. Okay, hope you understand. And direction is important. Okay, first I will check the loads are defined on shell is not. Yes, the loads are defined. Okay, now I'm going to give wind load, select. Okay, then first I'm going to give column and beam, select, assign, frame load, distributed, x direction, sting. Okay. Okay, then next is y direction, select line for column and beam. Then next for floors, shell load, uniform, again select y direction, direction y, and apply. Okay, then I'm going to select the walls. Okay, uniform walls, just going to elevation, okay, that is x direction and y direction. Select the walls, then sign for windward coefficient, that is 0.7, like, okay. Come to 3D. Okay, in this direction you can see it is applied. Now I'm going to give this direction, assign wind pressure coefficient in y direction 0.5, apply. Okay, you can check these directions. Now again this last option step is to analysis. Okay, uh, before analysis I'm going to click select all, assign diaphragm d1, apply. Without diaphragm there is no analysis for window. Okay, then last is check model, select all, click okay. Okay, the model has been checked, no warning messages were generated. Okay, then next is set load cases. Here you can make run or do not run keys. Okay, simply clicking on this action will show run, do not run. You can make any load as run or do not run. Okay, here from here also you can run now, or another option is to is analysis. Okay, I'm going to save. Analysis is going on. Here you can see. Okay, analysis complete. Okay, close this, and the last is analysis and results. Okay, here you can see loads at joint element 373. Okay, if you can check the animation also for displacement. And the next is to you can display your loads. Okay, undeformed. First I will make it undeformed. Okay, it's normal. In clicking display you can see force or stresses diagram. You can check the supports spring. It's for dead load. I'm going to check in fx and mx, my, mz, all the directions. Okay, here you can see the fx, fy, fz, all the thing, all the results are you can see here. Okay, like these combinations are also available. Mode is model, that models load also you can check. Okay, for different load also you can check the reactions also here available. Then next is come to display. Okay, now I'm going to show you the frame, pier, spindle, pling forces. Okay, it is dead load. Okay, and just simply click apply. Here you can see, you can see in thread also. Okay, just click on beam, right click it. As soon as you click on right click, you can see the diagram for B1. Okay, that is beam at story 4. Okay, I have checking for beam for a dead load, that is case, and equivalent loads are available, and shear force you can check here. Okay, by clicking arrow you can also check for a particular distance. Okay, see the value is going to change in positive or negative direction. Okay, and the bending movement also available in your results, and the deflection also available. The maximum, if you click on show max, it will show you the maximum deflection, that is 0.150 mm at a 1.5 meter. Okay, at a between, here you can see the direction changing from minus to plus, and bending moment here similar is deflection. Okay, absolute value also available, that is relative to frame minimum, relative to beam end, relative to story minimum. Okay, all the things you can check here. Okay, for every load you can check, it is available for every load case. Okay, similarly you can check axial forces also. Okay, for this particular building at dead load, click on apply, click on right click. Torsion is not happening here, but axial force is minus 27234.75, and equivalent loads are available. Okay, the major V1 and V3 shear force and movements. Scroll value means you can scroll and check the value at a particular distance. For live load also it is available. Okay, from here also you can change for axial. Okay, checking for this. Okay, done. And shear torsion also available. Okay, I'm going to show you shear. Okay, shear forces for this particular beam. Okay, then next is shell loads, shell stresses, or you can see for live load resultant stresses. I'm going to see, okay, deform shape or deform, undeform, extrude from, all the time, which type of contour you want you can make it here. Okay, if you make a deformed, scale factor or automatic, okay, apply. This is deform. If you make it undeformed, okay, like this, or have my maximum and shear be max, that is shear. Okay, show value or show line, you can click in and apply it. It will show the value, and contours also. This is the value. Okay, then show maximum flow and arrow. Okay, if you click on it, the maximum flow of arrow, it will show maximum flow of arrows. Okay, all these are on. Okay, show maximum arrows are only available at one time. Okay, then here you can see maximum for the changing value, you can see by changing your arrow. Okay, maximum movement we can check like this, or show value and to untick it. Okay, like this you can see maximum values at point. Okay, then for wind load also. Okay, like this wind load also you can check in x direction, y direction. Okay, close it. Then all the things you want to check in table format you can check. I'm going to make it analysis to structural output. Okay, base reactions and all, otherwise I will show you only base reactions. Okay, simply click OK. Okay, like this, click, right click it and choose it is dead load, load, and okay, apply multiple items in x direction x, in y direction fy. You can check dead load, live load, all the things. Okay, similarly you can see tables from here also, like data, frame design analysis, design preferences, all things are you can check from here. Okay, and analysis results are available here. This base reaction, like this. Okay, hope you guys understood how to load analysis and make a results, okay, of any building. Thank you.